So this you should initialize it to 1, because the number of semaphore, the initialization of the semaphore signifies the amount of resources that you have, not the number of threads that you're going to run. And what we have been talking about is called a binary semaphore. Non-binary semaphores are much harder to get right. Okay, so let's basically look at a parent waiting for its child again. How do we basically make the child, how do we make the parent wait for a child using a semaphore rather than uh, a lock, sorry, and the conditional variables. So you have these two pieces of code. You have the child code and you have the parent code. The parent will be the one initializing the semaphore. So let us ask yet another question. What should x be in this case? Should it be 1? No, it should be 0. Why? Because in this case, you actually do not want, you want any thread to come in to start. So thread that comes in, okay, the sorry, child thread that starts basically will start with a 0. It will start with actually without calling semaphore wait, because here you do not want the children to wait for anyone. You want the parent to wait for the children. And then if you need semaphores in the children, that's another story. But what you're trying to do is that you're trying to implement the you're trying basically to implement code that enables you as the parent to not progress, to not do any further processing. So if you initialize it to 0, the parent begins, the parent creates a thread and calls semaphore wait on each thread created, right? So if you have n threads created, if you have 10 threads created, if this was a loop and you have 10 threads created, the semaphore will basically, each time the parent calls semaphore wait, it will be the semaphore will be decreased by 1 to the total number of children that you have. And once you basically each child finishes, the child will call semaphore post. Sorry, we'll go through the code again. The child will call semaphore post, and with each child finishing, the semaphore number will increment until the semaphore becomes 0. And when the semaphore becomes 0, then the parent can actually proceed, because in that case, once the parent gets called, it will find that the semaphore value is 0, and it will proceed with whatever it's doing. Let's look at the code. So you create the child, you basically in the first step, and you have a semaphore that was initialized to 0. Okay, you call semaphore wait. Now you have -1. You decrement the semaphore. Now you cannot run anymore as a parent. You go to sleep and you switch child. The child runs, calls semaphore posts after finishing, increments the semaphore, and if there are no other threads waiting on the semaphore, because we said that the semaphore will always, once you do post, you will always wake one of the waiting threads. So you will wake the parent up. The parent now sees that the semaphore is 0. Okay, after basically post comes in and interrupt, and you have the switching, and the semaphore wait will return, because now it's, I mean, there is 0, and 0 is not less than is not a negative number basically. Okay, so this is how it is done. Okay,